Good morning to everyone. In today's video, we are going to see the application of network theorems to electrical networks, especially the superposition theorem. So already you may know that the superposition theorem deals with if the circuit consisting of more than two sources, okay, if the circuit is consisting of more than two sources, the response of the element, maybe the response may be the voltage or current. It should be the algebraic sum of, okay, it must be the algebraic sum of the responses when the sources are acting alone. Okay, so when you go with then a practical, an example, it is very easy to understand how they are, how this theorem is working. And now we are going to verify this theorem, that means the superposition theorem, through our MATLAB platform. Okay, so now I'm going to share the screen. Okay, so we know that this is our MATLAB window. So here I just want to do the simulations of, simulation of the circuit, which is provided through your Simulink model. So I just go in for the Simulink model. Once the Simulink model window is pop up, okay, Simulink model window is pop up, you can go for the browser for selecting the elements. So mainly I already stated in last two videos, when you're working with MATLAB, please be somewhat patient, because if you double click on the elements continuously, the pop-up windows will be appears, and each window carries a lot of energy. The MATLAB size is around 20 GB, so be somewhat patient while you are doing the work on your MATLAB software. So this is your MATLAB Simulink model, and here this is your Simulink library browser. Now we want to design an electrical circuit. So as I already stated that we are going to use the Simscape toolbox for designing our electrical circuits. So in that Sim Power Systems and that Specialized Technologies. So whatever may be the Simulink model, you have to start with your Powerjailbox. Okay, Powerjailbox helps for doing the computational facilities or graphical user interfacing elements here. Okay, so now for start our circuit, the most important thing is our source. So here now I'm going for an circuit which is having two sources, that is two DC sources. So I just simply selecting the DC source. Okay, so for my ease of convenience, I just provided the name as V1 and V2. So for the voltage 1, that means the source 1 is having the voltage value of 15 volts. Okay, 15 volts. And the second source is having the value of 10 volts. Okay, so in such a way I'm going to design. And whereas coming for the elements, okay, the rest of the elements, I'm going for the series RLC branch. So I already stated one point, series RLC branch, the parameters will be in form of resistance, inductance, and capacitance. You can able to observe the same sort of element here as a series RLC load. here the elements will be provided in terms of active power and reactive power. So while choosing your element, whether you have the values of resistor, inductor, and capacitor, you can go with the RLC branch. Or if you are having the active and reactive powers, you can go with the series RLC load. Okay. So now I'm having the resistors itself, so I can go with the series RLC branch. You may provided the name as R1, R2, okay. Otherwise, you can simply give that value names. Okay, so I just go with the resistor numbers for ease of my understanding. So I go for the 82 ohms resistor and followed with one more resistor and followed with one more resistor, which forms the tree circuit. So it is around 47 ohms. 47 ohms. Okay. So you have to rotate the element. Rotate. And whereas coming to this is 100 ohms. This is around 100. Now, as per the circuit, you are supposed to find out what is the current flowing through your 47 ohms. Okay, 47 ohms resistor. So to measure the current, I require the measurement unit. So now I require the measurement unit of ammeter. So ammeter should be connected in series with your line. So you may rotate the element. Okay, like this. So I just want to see the display unit. Here also I'm going to flip the element. So for that, the element, I mean, whatever the measurement block unit is there, it is not going to display. For current measurement, I just place. So this is my circuit. I'm going to connect this. So this is the thing. When I go for this, connecting this. Please remember, while connecting also, it should be in some sort of techniques are there. You should not overlap all the elements, or you should not connect zigzag way. Okay, so better try to connect circuit as simple as possible. Okay, so this is the circuit. Sorry, 1 second. Okay, so now I can able to run the circuit. So as I said, this is 15 volts, 82 ohms, and this 100 ohms, 47 ohms, and this 10 volts. Okay, so run the circuit and see what will be the current flow in your circuit. So compiling will be there. After that, your display will be complete. Okay, so it is displaying around 0.1385 amperes. Okay, now we have to verify this for the circuit which is having, I mean, the sum of these two will be full or not. So I'm simply copying it. Better. I will keep it in bottom way. And this is the first circuit. And the second circuit is this. Okay. So now I don't need this display box. I just make my screen in larger way for better to understand. Okay. So now I can able to see all the three circuits at a time. Okay. So here my interest is I just want to keep one source at a time. I just should keep one source at a time. So in the first circuit, in this circuit, I keep only V1 alone. Okay, V1 alone. And this circuit, I keep the V2 alone. Okay. Please understand one point. I didn't modify any element. The same ohms, okay, the same resistor values will be available. If you are having any doubt, please cross check. There will not be any issue. So whatever the voltages, all those things will be same. I just modify. In one circuit, I reduce the V2. I remove the V2. In another circuit, I remove the V1. That's it. Okay. So if you're comfortable, just run this. So now I got around 0.8953 and 0.4894. Okay. Now I go to add this to check whether this answer is right or wrong. Because as per the, okay, as per your superposition theorem, as per the superposition theorem mentioned, the summation of, the algebraic sum of the responses. Okay, the algebraic sum of the responses when the sources are acting alone, it should be equals to the both the sources acting simultaneously. The response of the circuit. So 0.8953 plus 0.04894. It should be equals to 0.1385. So when you round off this one, it will be 1385. So whatever the superposition theorem, okay, whatever the superposition theorem we studied theoretically in our class and do some numericals, right now we verified. That means we validate the superposition theorem through your MATLAB software. I hope it is clear for you. Thank you.